Welcome to qnawire.
What are the cell and glucose concentrations in the effluent of the first stage, and what are the product and substrate concentrations in the effluent of the second reactor in a two-stage chemostat system? First, we need to determine the steady minus state cell and glucose concentrations in the effluent of the first stage. We can use the Monod equation for this purpose. Mu equal to mu ms divided by Ks plus S. At steady minus state, the specific growth rate is equal to the dilution rate D, which is the ratio of the feed flow rate F to the volume of the first reactor volume. D equal to F divided by V1 equal to 100 divided by 5000, 1 equal to 0.2H minus 1. Now, we can solve the Monod equation for the glucose. Concentration S in the effluent of the first stage. 0.2 equal to 0.3 S divided by 0.1 plus S. Solving for S, we get S equal to 0.4 G/L. Now, we can use the yield coefficient Yx/S to find the cell concentration X in the effluent of the first stage. X equal to Yx/SS minus S equal to 0.45.0 minus 0.4 equal to 1.84 G/L. So, the cell and glucose concentrations in the effluent of the first stage are 1.84 G/L and 0.4 G/L, respectively. B. In the second stage, we assume that growth is negligible, so the dilution rate D remains the same. We can use the specific rate of product formation Qp and the yield coefficient Yp/S to find the product P and substrate S concentrations in the effluent of the second reactor. First, let's find the product concentration P in the effluent. P equal to Qp x V2D equal to 0.2 times 1.84 times 3000, 1 times 0.2 equal to 2.21,696 G/L. Now, we can use the yield coefficient Yp/S to find the substrate concentration S in the effluent of the second reactor. S equal to S in minus P divided by Yp/S equal to 0.4 minus 2.21,696 divided by 0.6 equal to minus 3.29,493 G/L. However, the substrate concentration cannot be negative. This means that all the glucose is consumed in the second reactor, and the substrate concentration in the effluent is 0 G/L. So, the product and substrate concentrations in the effluent of the second reactor are 2.21,696 G/L and 0 G/L, respectively.